Hey YouTube, it's Taylor the Gun-Toting Atheist, and today we're going to talk about nuclear optimism. First thing first, let's clear something up. I don't want to hear any of you dumb motherfuckers saying nuclear weapons. I swear to God, if I hear that one more time, I'm going to choke you until all the extra U's leave your body. So there's two different ways nuclear weapons work. One is with a gun-type device, and the other is with a bomb-type device. Your gun-type device sends a projectile of fissile material into a target of fissile material, and this initiates the chain reaction that generates the explosion. In a bomb-type device, you'll have a sphere of your fissile material, and you'll surround it in a special material that under pressure, a special metal that under pressure releases neutrons. This pressure is initiated by a series of explosions initiated on the outside of that sphere. This generates the chain reaction. There are two different types of nuclear weapons. There's fission and there's fusion. Fission reactions are the ones that most people are familiar with. Fission uses plutonium or uranium or another heavy and relatively unstable element, and it uses neutrons from one reaction to split atoms that release energy and release more neutrons, generating a chain reaction. This is the basis for how all nuclear weapons work. They release a lot of radioactive particles, and they tend to have the most fallout of the two different types of nuclear weapons. The other type of nuclear weapons are fusion bombs. The other type of nuclear weapon is fusion bombs. Now these use a deuterium and tritium mix, which are both forms of hydrogen. Now when they're fused together, they create helium and a few extra subatomic particles, and that also releases a lot of energy. These bombs use a small amount of these materials, and the only thing that can initiate the pressure and temperature needed to generate nuclear fusion is nuclear fission. So with these bombs, there's always a small fission device to initiate the fusion explosion. Fusion bombs tend to be a lot cleaner since it only requires a small amount of fissile material to initiate the fusion chain reaction. There is another subcategory of nuclear weapons, and that's neutron bombs. These are fission bombs, but they differ slightly as in the fact that the neutron shields, which are just metals that help reflect neutrons and X-rays up into the mushroom cloud, are now replaced with lighter materials that allow the neutrons to pass through. This creates a lot more radioactive fallout, and it bombards the affected area with neutrons, which we'll talk about a little bit later. So when there's a nuclear bomb, obviously there's a lot of radiation. This is something a lot of people like to talk about, but a lot of people don't know a lot about it. There are 5 primary types of radiation that are of military concern. The first is your alpha particles. And your alpha particles are basically helium nuclei, so there's no electrons attached, just the helium atom itself. And they're very heavy and they're very slow because they're so large. They have so much surface area compared to other subatomic particles. Another kind of radiation is beta radiation. This is the opposite side of the spectrum as alpha particles. These are just electrons that have been stripped from atoms, and they are free-flying. Because they're smaller and lighter, they tend to have higher penetration capacity. Alpha particles will be stopped by thin clothing and sheet of paper and even your skin. Beta particles can penetrate a little bit deeper and go about halfway through your skin. If ingested, these particles have a harder time leaving the body because of the skin, but because of the soft nature of your internal organs, can cause a lot more damage. As mentioned earlier, there are also neutrons. Now neutrons are subatomic particles that are that comprise the core of most atoms. The reason that neutrons exist is to help disperse the positive forces of the protons inside the atom. Because if there was no neutrons, then the protons would just fly apart because they all have the same charge and they don't want to be around each other. They like opposing charges. Now if you want to know why electrons aren't in the center attached to the things that they're supposed to be attracted to, ask a particle physicist. I don't fucking know. Neutrons are very dangerous because they're so small, but they still carry a lot of weight. They carry as much weight as a proton, but protons normally aren't free-flying in these types of environments. But protons and neutrons weigh more than electrons. Because of this weight and small size, the neutron acts more like a bullet or almost like a bowling ball. Because of this, neutrons can damage many layers of the body. Next up, we have X-ray radiation. X-ray radiation, I'm sure most of you are familiar with and have been exposed to in your lifetime. X-rays penetrate soft tissues and are reflected by hard surfaces such as bones and concrete. high exposure to X-ray radiation can cause cellular damage, which is why when you go to the dentist, you wear a lead vest. I always use lead vest to cover my balls. And the last type of radiation that is of military concern is gamma radiation. Now, like X-ray radiation, it's on the electromagnetic spectrum, which means that it travels at the speed of light. But if you ever observe the electromagnetic spectrum, you will see a difference in all forms of radiation, and that's the frequency. Because of certain frequencies, you'll have things like broadband FM, which is radio waves on the far left-hand side of the spectrum, and then as you get to the middle, you'll have visible light spectrum, which the frequencies are just the right size that our eyes are adapted to be able to see it. Some animals, such as pit vipers or bumblebees, have the capacity to see a little bit past the visible light spectrum into ultraviolet and infrared. Gamma radiation is on the far right side. It is the most extreme form of radiation. If you look at the frequency of electromagnetism, you'll see that it follows a wave-like pattern. Now, radio waves are very wide and very slow-moving, but along this pattern, they have to move faster than their radio wave counterparts in order to cover the same distance as the radio wave counterparts, because they're moving over such a greater distance in that compact form. So to cover the same real distance, say 1 meter, it has to move through its oscillations faster than a radio wave would. Both move at the speed of light. Next up, we have fallout. There are three types of fallout. You have your light fallout, your medium weight fallout, and then your heavy fallout. So your heavy fallout is going to be washing machines, dead cats, car axles. Then you have your medium fallout, which is going to be the stuff of primary military significance. Your heavy fallout stops falling between 30 and 90 seconds after nuclear detonation. Your medium fallout is going to fall from that time frame to about half an hour out. This is going to be stuff like ash, burning paper, things that are light enough to travel relatively far, fall for a relatively long period of time respective to combat situations, and still carries a high volume of radiation. Then you have your light fallout, which can fall for up to several years after the detonation, depending on weather patterns and the particulate value of the area that was hit with the nuclear explosion. Categories of nuclear explosions. You have your underwater blasts, which are typically used for naval battles, but in the capacity of sinking ships are not highly effective. However, underwater blasts tend to release the most radioactive fallout. You have your underground blasts. These are typically used for nuclear tests. Originally, the concept of underground nuclear explosions was intended for mining, but because of radiation concerns, it was canked. Then you have your surface blasts. These are detonations that occur directly on the surface and tend to release the most amount of radioactive fallout for a surface explosion, but also have high geological value. Basically, the shockwave hits the ground more, so you have the potential to destroy underground infrastructure better than the next two forms of explosions. If your low altitude detonation, this is the most significant type of nuclear explosion you can have. It occurs over the surface of a target, and the explosion still kicks up a lot of debris and releases radioactive fallout. However, the fireball, since it is higher, more diameter of it is allowed to cover the surface of the ground, destroying more of your target. Then you have your high altitude nuclear detonations, and these are of high strategic value because if the nuclear explosion occurs over the Earth's magnetic field, then the radiation from the detonation that hits the atmosphere can generate an EMP, or an electromagnetic pulse. This can knock out unhardened electronic devices such as cell phones, televisions, cable networks. A good rule of thumb is the more complex the electronics are, the more susceptible they are to an EMP. Very basic electronic devices such as the automatic windows on your car or a transformer are not going to be very susceptible to an EMP. And now a brief history. The first nuclear weapon ever detonated was the Gadget, which is detonated at the Trinity site in the deserts of New Mexico. In order to preserve life and reduce wartime length, the decision was made to drop nuclear bombs on Japan. The first was dropped on the city of Hiroshima. The bomb was codenamed Little Boy, and it happened on August 6th, 1945. Hiroshima contained the command element of Japan's Second Army and was a hub for communications and staging troops. Since Japan didn't surrender after the first nuclear strike, a second nuclear strike was initiated with the bomb of Fat Man on the city of Nagasaki on August 9th, 3 days later in 1945. It was of high strategic value because of its many varied industries, which included the production of ships, military goods, munitions, and was one of the largest port cities in southern Japan. So as you can see, the targets were very specially selected to try and end the war as quickly as possible. World War II, that is, in case you didn't know. Because of a whole bunch of political bullshit that I'm not going to get into, once World War II ended, the United States and the former Soviet Union joined into what was known as a Cold War. A Cold War is a war with casualties but no battles. The Cold War initiated a lot of research and development into different types of nuclear weapons and the delivering capacities of those nuclear weapons, such as multiple independent reentry vehicles, rocket delivery, aircraft delivery, submarine delivery, the list goes on. On October 30th in 1960, the former Soviet Union dropped a 58 megaton yield nuclear bomb on an island in Siberia. The bomb was originally intended to be a 100 megaton yield, but that kind of scared them, so they reduced it down to 50 megaton yield of fusion material and then an additional 8 megatons worth of fissile material to initiate the explosion. The blast was so powerful that the shockwave hit the ground and bounced up, preventing the fireball from hitting the ground. The fireball became so big that it reached almost the height of the delivery aircraft. The shockwave was so powerful that it traveled around the world 3 times. The explosion released approximately 5.4 yodawatts of energy. I found an unverified source that this is approximately 1.4% of the sun's output. I believe per second, but there's a reason I'm letting you know that it was unverified. At 55 kilometers away, all buildings, wood and stone, were leveled in select places. Over 100 kilometers away, most wooden structures were destroyed and stone structures lost their roofs. The blackened crater from the explosion is so big that it can still be seen from space today. And now my favorite part, the reasons we should keep nuclear weapons, both the likely and the less likely. As Kenneth Waltz, the leading nuclear optimist and professor of political science at UC Berkeley says, "We now have 64 years of experience since Hiroshima. It's striking and against all historical precedent that for that substantial period there has not been any war among nuclear states." An example of this quote would be Pakistan and India, who have had 3 bloody armed conflicts. But since acquiring nuclear weapons, neither have stopped hating each other, but neither has gotten back into a war with the other. Further justification is that acts of war tend to only be carried out by national leadership that think they can get away with it. Nuclear weapons are a game changer. They make the cost of war both very clear and unavoidable. They also make that cost very high. Because of this, initiating a war with a nuclear state is not really pragmatic. And because of that, bilaterally nuclear states typically don't initiate conflicts with one another. At the very worst, there is the concept of MAD, which is mutually assured destruction. Basically, if Russia or if the United States launches a nuclear weapon at the other is going to send all of its nuclear weapons, and then the other will send all of its nuclear weapons, ensuring that both nations become nothing but ash and crisp. This is a really good concept, and it's a really good national policy because it is very self-serving that you do not send nuclear weapons. It's very mutually beneficial to know that your opponent is going to send everything they have if you send anything to them. And then if they send anything to you, you'll send everything you have. Basically the same argument for concealed carrying firearms. Now we get to have the fun part of this video, which is unscripted, because I'm an unprepared dipshit, and I really like it because people always tell me I'm wrong, and I am astonished that they don't think about it. My first thing is zombies. So it's kind of silly, I know, but if there's a zombie outbreak somewhere, you can use nuclear weapons not as a deterrent like you can with a sane, healthy state, but as a form of resource denial. Now, if an outbreak starts in a city, say New York City, and you catch it, and you know it's there, and you know that it's spreading, you can deliver a nuclear weapon to that city and detonate it. And now, depending on the yield of your explosion, you have 20 million potential carriers of that disease now gone out of the equation. So if it started in Maryland or New Jersey and got to New York, and you have already quarantined those areas, but you can't quarantine an area the size of New York. And remember, this hypothetical situation, I don't live in that area, so if I'm saying something a little weird and you live in New Jersey, then I'm sorry. But if you can't quarantine New York, but you've already quarantined the other beginning areas, then New York, with all 20 million of its people, can create a very large dilemma for containing such an outbreak. So resource denial is one alternative that you have. And it's very scary, but it's important to have options, because what's more scary than destroying one of your own cities is allowing all of your cities to be destroyed by something you could have controlled. Another possible option with zombies and nuclear weapons is area denial. Now, this is a military tactic that I'm not going to cover too much of the military aspect for, but it's the same concept. If you have botched the control of an outbreak, and a perfect example would be Miami, or just anywhere in the southern regions of Florida, it's going to begin spreading north into the other regions of the United States. And because it's a peninsula, a quarantine would be very easy, but the border between Florida and Georgia is a very large area, and manning that would be very expensive, both in life and money. So another way to control that would be potentially to set up a nuclear strike all along that border. Now, again, that's not ideal, but if you have to control an outbreak, that's what you can do. And now, some people are going to be like, oh, you're going to have radioactive zombies. But in reality, the zombies that are traveling through that irradiated area are going to take on significant biological damage. Now, the other less likely scenario is aliens. Now, of course, as a policy, if aliens are ever encountered, you should never resort to violence as your first situation. Never enter diplomacy with violence. But if aliens do attack, then you can use nuclear weapons to defend yourself. Now, a lot of people use the argument of, well, if this species has mastered faster than light travel, they're probably prepared for nuclear weapons. But something they don't take into consideration is that the environment under which intelligent life can evolve is most likely diverse, and it doesn't have to mirror the development of human life on this planet. Basically, what I'm saying is that where other intelligent life can develop doesn't necessarily need to have heavy elements like plutonium or uranium naturally existing. And if this is the case, then the idea of nuclear fission as a weapon may never even come up in that cultural development. So if an alien race has developed somewhere that doesn't expose them to fissile material, then they may have never developed that. Without development, there's no immunity, because, as we all know, exposure breeds immunity. I made that quote up, by the way. Anyway, there's also the fact that we don't know what their bodies are made of. So, if an alien race comes and is violent, then radiation from fissile material could be the best answer to fighting them. After all, we know that what it does to us, such as in Pacific Islands, nuclear tests, the neutrons released from those nuclear tests irradiated the soil, changing potassium and other critical elements for human growth to become radioactive. They were then absorbed by coconut trees and then began poisoning the local populations. Something similar can be used against alien races. And finally, I mean, you say that whatever, aliens are gonna be protected from nuclear weapons, but can you prove that? 'Cause I'm pretty sure you can't. So keep your options open as far as defense strategies are concerned, because you never know what may come in handy. Have you seen Signs? Water killed those aliens, which, by the way, I hate the plot because it was full of holes, I think. But that's a different story. The biggest argument against nuclear optimism is that leaders are crazy. The people today are crazy. And we would be foolhardy to trust anyone with nuclear weapons, especially if they know that we have nuclear weapons, because if we have nuclear weapons, they're going to use our nuclear weapons against us, and we're going to use our nuclear weapons against them, and they'll use them against us, and we're all going to die. But in reality, are Ahmadinejad and Kim Jong-un really more crazy than Stalin and Mao were? History repeats itself. And if we haven't had a nuclear war in 64 years, chances are we're not going to have one for another 64 years. And this can best be explained with the quote, "He who knows not his own history is doomed to repeat it." And with that, I'll leave you for next week.